Okay, I know that these problems look complicated initially. Take time to read them, please, because they're not as complicated as you might think. I'd like you to focus in on this second sentence right here. It says, in normal atmospheric conditions, F sub L is the frequency of the listener. So that's very logical. F sub L is the frequency of the listener. F sub S is the frequency at the source. Okay, so that's something that we're going to be looking for. Velocity is just simply the velocity of the sound source. Notice that it says miles per hour, so that's something important. So here's our little formula, and here's all the information. So let's start with the formula and figure out what we need and what we already have. It says, what frequency do you hear? So that's going to be the frequency of the listener. So that's what we're looking for, frequency of the listener, all right? The 740 times the frequency at the source. So, well, we know this is 740. Have we been given the frequency at the source? Well, it says you're standing still and a police car is moving away from you with its siren blaring at 1800 hertz. Okay, look, people, that's the frequency at the source. That's where the sound is coming from. So that is not complicated at all. And if you make it complicated, I don't know, I can't help you. All right, so the next part is 740 minus the velocity. Well, that feels pretty straightforward as well. 740 minus the velocity. Well, velocity is 6,000 feet per minute. Okay, not so fast, not so fast. Because watch, it says the velocity has to be in miles per hour. Here they gave us the velocity in feet per minute. So that is going to take us a little bit of time. I'm just going to jot this down using conversion factors, and I want you to work this one with me. Do not just copy my answer. You write this down with me. So 6,000 feet per minute, we need to change it to miles per hour. Well, let's change the feet into miles, first of all. 5,280 feet in 1 mile, okay? So there's that. And then we need to change minutes into hours. Well, there are 60 minutes in 1 hour. Now, you should know by now that the way that you choose how to use these conversion factors, this is a conversion factor, this is a conversion factor, the way that you choose to arrange these has everything to do with what you want to cancel. I put the feet in the bottom here because I wanted these 2 feet to cancel, all right? I put minutes, 60 minutes over 1 hour this way because I wanted these minutes to cancel. Notice I'm left with miles per hour. Miles per hour, which is exactly what I wanted. So all I have to do to figure out my velocity is just take 6,000 times 60 divided by 5,280. Now, if you did that properly, you should end up with 68.18. All right? And then when you do the math on this, well, I'm going to let you do the math on that. I'm not going to give you the answer because I've done the hard part for you.